In this video, we'd like to go over implicit differentiation. So first, let's start with this equation, x squared plus y squared equals 1. This is the equation of a circle, and suppose we want to compute the tangent line, say at this point. Then we'll need to first solve in terms of x so that we get a function in terms of x. That'll spit out this value here. So we'll just solve for y in this defining equation. Then we can take the derivative, find the slope, and form the equation of a tangent line. But what if we want to find this equation, the slope of the tangent line down here? If we solve for y like this, it seems like we'll just get this, but we're forgetting that when we take the square root, we'll get minus. So actually this side, we'll use this function, y equals minus square root of 1 minus x squared. And then we can take y prime, find the derivative, and plug it in, and find the slope, and form the equation of the tangent line from there. So it seems like when we're on this side or this side of the circle, we'd have to use two separate equations. But implicit differentiation is one way to avoid having to solve for y and just take the derivative from this equation. So how can we do implicit differentiation? Well, imagine y is going to be a function of x. Let's rewrite this as y equals f of x then. We can rewrite this equation as something like this. Now let's take the derivative of everything. So the derivative of x squared is 2x. Now how to differentiate this? This is a composition of the function, the square function, and just some function f. And so we'll have to use chain rule. So we'll have 2 times f of x times f prime of x, and then the derivative of 1 is just 0. Well, let's substitute these back here. Y is f of x, and what's f prime? Well, that's the same as y prime. So we can replace f prime with y prime. Now we can isolate y prime so that we'll get y prime equals negative x over y. And so this will give us the slope of the tangent line at points where y is not equal to 0. So let's say we want the slope of the tangent line at this point, which would be 1 over root 2, 1 over root 2. Then y prime is negative x over y. So plugging in these two, x and y, we get negative 1. So the slope is negative 1 here. Let's say we want to find the slope of the tangent line at this point here, say negative 1/2 and negative root 3 over 2. Then y prime is negative x over y, and so we'll plug in negative 1/2 and negative root 3 over 2, which becomes negative 1 over root 3. So if we want to find the equation of the tangent line, we can do y minus the y value here equals the slope times x minus the x value here. And so in this case, this will be the equation of this line here. Let's do one more example of implicit differentiation. Suppose we have this rather complicated equation and we want to find y prime. Well, solving for y, that is isolating y and having only x on this side so that we can take the derivative normally, is impossible, probably. Looks very hard. Using implicit differentiation, we can still find y prime. Of course, it will depend on x and y, but not on y prime. So to help with the notation, let me rewrite this as this equation. I rewrote y as some function y that depends on x. So that means you want to use chain rule each time you want to take the derivative. Now, for this one, this is a product, so we'll have to first use product rule. And so this will be the derivative of the first term, which is 2x times y cubed, plus x squared times the derivative of y cubed. Now here, when we take the derivative, we'll use chain rule, and so this becomes 3y of x squared multiplied by the derivative of the inside function, which is y prime. And now let's take this derivative. This is a composition of the function sine and y squared. So we'll take the derivative of the outside, which is this cosine. We'll need to multiply by the derivative of the inside. The derivative of the inside is another chain rule. Multiply 2 times y of x times the derivative of the inside, which is y prime. And finally, the derivative of x is 1. The derivative of y is just y prime. Now, we didn't really need to write down that y explicitly depends on x. This is an implicit differentiation. So let's just write out the equation a little bit cleaner. This will be something like this. When you get more comfortable with taking the implicit differentiation, you'll just go straight from here to here. Basically, whenever you need to take the derivative of y, you'll use chain rule and make sure you multiply by y prime. And now we isolate y prime. We'll move everything with y prime to the right hand side, and we'll move everything without y prime to the left hand side. The reason we do that is because we can factor out a y prime here, and after all that's said and done, we can isolate y prime, and so we find the derivative y prime is this expression.